Okay, so I'm gonna give you a bit of an explanation on how the current superpower search architecture looks like. Basically, you understand what we're doing and how are we getting the SPK keys from the repositories, and that there could be also some input from the community in this architecture and make it a little easier for you to kind of find out what's going on. Now, I'm using the component builder repository because all the code that obviously needs JCB to work is always going to be in the component and the plugins. So JCB is shipping with every part of the application that it needs to build extensions. So that means we have all our code in this library folder under JCB powers. All of this code is basically being used by JCB somewhere or another. That means we've also got the Git library here, and eventually there will also be a open API, open AI library, which I'll be adding soon. In fact, we are nearly finished with that. So, but looking at um, our new search algorithm, it's it's actually interesting to see how it works. So first of all, this is the folder where all of Component Builder's core classes and stuff is found. Um, and everything regarding the compiler that is exclusive to the compiler is found there. That means this layer of files is basically what JCB is using exclusively to the component builder. Now, if you go up to this layer, it means that this utilities file is not exclusive to the component builder. I have other extensions that also use the utilities files. So this is kind of how you should start thinking about my file structures. My file structure kind of the more applications or people use a specific code, the higher up in the file system it will be kind of placed. And the more exclusive a class becomes, the lower in the file system or deeper in the file system it's found. So for example, if you want to see code that is exclusive to the compiler, you basically go into the compiler folder. If you want to see code that is exclusive to the component, then you go into the component folder. So all of this code is exclusive to the component. Now you may on this layer also found a component file, which is usually the base file that makes use of all those files in this folder. Not always. It's just the way I think about my structure is more or less exclusivity has depth, and generality or um, being all inclusive to other useful application is higher up in the folder structure. This is just for myself. If I'm looking for something, I basically start with who is using my code. What program, what application? Okay, well, it's component builder, but it's okay. So next up, uh, is it being used in more than these subfolders? Yes, abstract classes, for example, all these abstract classes are used in multiple of these subfolders. So that means it needs to be higher up. So these base classes are now, again, if you're going to the compiler class and you go to the, for example, the registry class, you'd see that it extends the base registry. So and you can see where obviously that base registry is located. And this is the general flow of how I think. Okay, that's just a kind of side, a bit of information. Now we are basically going to search for things, but we are searching for power, and these are the main classes that we will be using in the superpower search. Basically, we have what I've called grep. Now, it's just a global resource empowerment platform. My own acronym, but also want to give you the idea of we're searching for things. It's not regex related, so that's why I gave a kind of a definition to what we are doing with the word grep. But this is basically the application that does the searching work. So it has different order of how it can search. It can either start its search local and then do remote, or just local, or just remote, or first remote and then local, depending on how you pass the array of those two keywords. And eventually we could add more places to search. Now, obviously, grep is only used if we already looked in the database. So the database is not even part of this search. And this search now has a specific way of looking for the specific class by its unique global unique ID of the power class. And so here's our order array. We are simply looping through it. And we are, from this target, getting the function name. This gives us the option to have a function name that's not necessarily exactly the same or whatever. So we have this separate place where we're going to determine, based on this key, what is the function name. And if we are found that there is not such a thing, we will return null. So it's a simple safety that if somebody passes in a wrong value here, we'll basically end everything over here. We won't go further. But if we do get a good valid class function name, we're basically going to call that function with the global unique ID value. So here we do a search local, and here is the search remote. So the search local, it depends on path and paths, which if you look at our init function, as basically our constructor, we have a little init that always triggers the moment the class is instantiated. And the class obviously requires all these dependency values, of which they are passed in through the container. So we don't really care about where it gets at. It should pass it in, otherwise it obviously won't work. And so this init function, it actually does a few things for us ahead of time. First of all, it validates that we have our values. Secondly, it then tries to actually find the, there is in the power, if you look at the power, let me just go there quickly, a superpower folder like the compiler. This superpower folder, each one of these classes have a setting file, but the base has a superpowers JSON file. Now this is the file which we're basically using to do the search, and it has the global unique IDs as keys to the actual location and all of the information about that specific class. So this means that within our search, whether the data is local or whether it's remote, we are going to look for that specific file. So as you can see, let's say we are going to do a local search. We're going to first check, do we have already, because you see with the init, wait a minute, it happens at times that you are going to be calling the same global unique ID multiple times, right? And we don't want to do the whole search if we've already found it previously. So this extra catch here is if we already found it, then we already have the settings of the file set, and we already have the code name value in place. And so in that case, we just return a null. Wait, let me, I messed that up. This actually says we don't have it in our memory. So the init function pulls up all the repositories, that is the approved path. So if you look in your component in the superpower area, you basically have all these repositories, and they are considered as paths. So you see there it says paths. And so when we look at the code again, these paths are looped over, and we are taking the owner and the repo and we are building the path, as you can see. And then if it's default, we leave the branch as null, and or if it's just empty. And then we basically build the full path, and that's really it. So this is the init function. We're simply setting up the more detailed aspect of the of the information that we're getting from the database. One thing that also is important here is if we have a local path, which if you look at the config again, it's this value here. If we have that value, then and we check that this value path exists, then we put a full path, which is the local path. Okay, so this is part of what the init does. And in that process, we are now basically ready because we've updated the local. Let me see this. I think I jumped a function here. Let's see, search local, get. So yes, there it is. Local index. This is the function I skipped. That's why things were not making sense. And this local index basically, it first obviously validates that we do have paths and that we can do the search locally. And if we do, we are basically indexing this specific repository. So see, we're looping through the paths, right? And so we are indexing this specific repository here. And what that actually will do, if we go to this function, it obviously checks again, blah, blah, blah. And then it tries to retrieve that superpower folder, JSON file. And if it is a valid JSON value, we actually place that into the path's local value. And if it's not found, then we obviously make that value null. And that's why when we then get to the get local, if this does not exist, then it actually means that we don't have that repository locally, and therefore we return null. So there we go. Well, if we do have that value, we then do the fetching of the settings of that specific class. So we're basically now, if you look at the repository, we are using this value here. And basically that would give us the source inside here, settings JSON. So it'll give us this values. And if we do get a valid JSON, we also convert that again. And now, since we found the class, we basically are only going to pull the actual power value. And looking again at our previous example, let's see, where was it? Here. The power value is basically the path to the code power file. So it's the raw data from the database that we stored for that specific power, which then is this file here. Now, why is this the file we want? Because all the, when JCB compiles anything, it's looking for language strings, it's looking for custom code, and it updates those placeholders so that once the code gets into the actual extension, it is now ready to be executed. And so we want to use the version of the code before any of that update is happening. And that's why we have this raw version, because in some classes we might actually have language strings and stuff like that. So it's the unupdated values that we are pulling. And so that's happening at this very moment here. Because we're working with local, we're just using get content from the file helper static class, abstract class with a static method. and we're adding it to our main class code, which is in the database the actual field name for that for that value, and we return the power. We're done. We found the power. We're not going to search any further, and so it means the first path that has what we're looking for is the one we will use, even if it exists in lower of any of the lower paths. So if you look at our config, even if a class exists in this one again, if we find it in the compiler class, we'll stop immediately. So that's part of what we are trying to explain here with the algorithms, the cascading algorithms, the way the JCB task gets power. So we're trying to explain this cascading effect. So the highest value is the one that is being kept. Okay, having said that, if we looked through all the local repositories and there did exist any or none, it doesn't matter, and we didn't find it, and we actually did add the remote ordering to search remote next, then obviously the next function we are going to load here is the search remote. So the search remote also has a remote index method, and so we could look at that. The remote index, there it is. So in the remote index, we are going to do a try catch because we are now using the API. And this contents, if we look at the beginning of our class, we see that we are passing contents in, and contents is actually the Gitty repository contents class. So if we go up here, we could see that it's this class that we are, is a dependency for this grep class, which it will then use to, and there's the file helper class if you want to check that out. And so that means we are going to try, where was it? I scroll. Get index, yes. Local remote index. We're going to try and get the remote, the owner and the repo, and the actual file we want, and the branch. Now, this is where the aspect of the branch plays a role. If we left the value to be default, then within the init process, it would have been set to null. Now, when we pass null into this content get method, basically that value is not passed to the API, which means it will return the default branch set in the Git repository on the API, on the Gitty system. Which was a mistake in my previous tutorial. I said it will default to master, which is not the case. It actually defaults to the default of your branch, which being either main or whatever the case be. So that's actually, that's the expected behavior. So that's actually correct. And though if you want to target another branch that is not the default branch, then you should put the name in and it will actually pass that branch to try and retrieve the superpower JSON file. And when it does get it, obviously, then we're good. But if there is a problem, we're going to pass the issue to the application. And we're going to queue the message, and we're going to set the index to null. So that means we're basically saying, nope, nothing here. And then if we didn't find it, coming back here, we're going to check, is the index null? Yeah, then we're done. Try the next path. If it's not null and it has a value for the global unique ID, we're going to do get remote. So we're going to search into that specific repository. And so get remote, I scrolled past it again. Here it is. Again, we are doing a little bit of extra validating, checking, do we have settings and do we have code? If not, then we're also not going to continue. But otherwise, we're going to load remote file. And loading the remote file is this one here. Wait, here it is. We're basically using the same method, contents get, and we're just passing the values directly. So nothing fancy, and we are catching it if it fails. Otherwise, we are retrieving or returning the data. So it's either null or the data itself. And our get function, this contents get function, it has the all the code in it to extract the response that we are looking for, or to throw an error. Yeah, to throw an error. So that's how we searched for the remote. And if we found something, oh wait, whether we found something or not, we are going to return it. So it's going to either return null, because here's the point. The only reason why we will go on is because we found the... Now this might be a bug. I need to think about this one. Because here we are basically detecting, this repository has this class. That's what this line is doing here. And therefore, we're going to try and retrieve it. And we should probably, if it fails, continue searching instead of just bombing out. Okay, I'll fix this. It always helps me to explain what I've done to someone else, so I could pick up things like this. Okay. Nonetheless, this is how the search remote works. And once we discover the class, we're basically just giving it back. So going to our super, which is the actual entry point, you see that we have grep here, and we have insert and update. Now insert and update comes from, I think, the database class. There it is, insert and update. And we also have a model class, which basically extends our abstract model. So again, we think about this is a model that is used by many other classes. So it is a layer up. So if we go up one layer, it's over here, and there it is. This is the model. So you could look through the model. It basically has a class method here that needs to be overwritten, that tells us how to deal with the actual individual value. This method here stores an item or models an item, and as you can see, here it has the validate before the modeling, and here it has the value. See there, it's dealing with the actual value, and then here a validate after, and then set it into the bucket. Now if any of these validations fail, of course we're just going to skip this value, this item, the field, specific field in this item. And here we are counting our fields, and we're making sure that we have at least more than one field, and if we do, we return the bucket, otherwise null. And so here in items, you can see that we are going over all of the items in this manner, modeling them. And this is how we deal with a row, and this is how we deal with rows. And here's a counter for the last modeled ID, which is a useful thing if you want to get that ID of anything that's been modeled last. Let's see here. Get table fields. Now the get table fields is going to call the table class. It's going to make sure that we are actually injecting fields here, updating modeling fields here that are legitimate to the actual table. Now this table class is part of something JCB builds. JCB builds the table class during the compilation. For every view that is having a database, it is actually building up all the fields that it needs to populate this view. So that is a useful function that we've introduced. And here's the validate before and validate after and get table. Now the get table is just to know what table are we working with. And so it's a very abstract basic class. It's very useful. I know people might not agree with me. I don't really care. I find it very practical. So that all said, let's go back to our Power super area here. And you'll see I'm pulling um, the insert and the update. Okay, let me see if I go to the database and I'm doing the update. Okay, here I'm pulling in the model. That's it. And then I'm using the model before I'm updating anything. Here I am modeling it, and then here I'm updating it. So that's kind of the architecture for that. That's how all the powers, when we discover any of the powers, before we then put it into your extension, we're actually taking that model, that power, and we're modeling it so that if anything needs to be JSON encoded or needs to be base64 encoded. In fact, I could show you that. If we go out here and we go into this model, you see that here we are saying, you see the table class, it also gives us another feature, and that is how is this value being stored? How do we store this value? Because JCB, while it's compiling your extension, you already are telling JCB, okay, this is a JSON, this is a base64, this is that. I mean, if you think about, let me go out here. Think about a field. So any field that we create in JCB, you are telling me how it's going to store, modeling method. You see here is a lot of modeling methods, and I can act upon that modeling methods in my in this here I can decide. But because I know, because of that value here, the get table, I know that we are working with power, and power actually has only 3 modeling methods: none, which meaning just take the value, set it into the database, or base64 or JSON. Those are the only modeling that is needed for these values, nothing more. That's why I only had to add these 2. So that's the idea about the value method, is that we can now, because JCB in this table class, now we can look at this table class. It is, let's see, where is it? It's coming from our abstract model, so let's go back, wait, over here. Abstract model, we open that one up, we see that it's the builder table, so we go up again, because it's used everywhere, we place it up very high, there it is. Now it's huge, it's going to take a while to open because JCB has many tables and many values in tables. So this is a very big class, but as you can see, it gives us the table name, it gives us the field name, and it gives us in here again the actual label, the type of value we're working with. Is this a title field? Yes, true. In the list, what is the view name of the list view of this field? Is there any specific storing instruction? In this case, no, just save it. And then what is the tab in which this field will be used? And this is details. So these are the values currently that we are storing per field. And if you look in JCB again, and I go to power and I search here for table. Okay, so there is JCB table. You'll see that I am simply using this placeholder. All component fields. That is the placeholder that if you create such a class for yourself, you could call it whatever you like, right? I mean, you don't need to do it the way I did it. You just need to remember this is the placeholder. And in any power, anywhere where you put that placeholder, JCB is going to put your components, that your specific extension that you're compiling, it's going to put this value, which is massive. Okay, it's in JCB's case, it's huge. It's basically a very big array. Okay, that's what it generates, and it's going to put it in that file for you, which I think is useful, and I'm using it. So here I wrote a few functions. Now it's basically what you see here, and so I wrote a few functions. One of them is a get function, and the get function, depending on how much you are passing to it, it gets granular. So the more specific you want, the more the table name, the field name, and what value of that field you're looking for. You see, that's what this does. And based on that, it actually returns for you. Now, if you pass the keyword all, then it will actually take return all of the fields for that specific table that you wait a minute. That's right. If you pass a table value here and it's not all, because you can't not pass something. So if this is all, if this value here is all, it's going to fall back to all. And it's going to give you the whole thing, bang, like that. But if you actually have a value and it actually exists, we are actually going to return that table to you. Otherwise, we're going to say, no, it does not exist. We're not going to go through to all. And that's kind of a catch to make sure that you don't get an unexpected result. So you're looking for something. So you can't call any table all. Maybe we should put that in all caps. It's a little late now. Okay, anyway, so here is our little documentation about that. And then you could check, is the field a title? What is the title field? That's right, what is the title field of this table? And it's going to get you the title field and give you the whole item. There's going to get you the title name. There's going to give you all the tables. There's going to just check if the field actually exists. There's going to get you just the fields. And here it's going to add the defaults, which are the kind of values that, you know, your database might have these values and you want to basically deal with all of those rows, but they are not by default part of our data set. Our data set only loads the fields which are not default. So that basically means those that you've added. So anyway, that's the table class. It's a powerful tool. I am using it these days quite a lot. It's a different way of dealing with the tables than Joomla's own approach of model view controller thinking. This is more an applicational design where I can validate that the data that I'm using is actually matching up with the table that it's intended to go to. Okay, so that was that. Going back, wait, that was too far, to our, here we have our update. So again, our update has the model, it has the database. Now the database, again, this we could see, where is this? Okay, that's database update. So let's do that. Going back up here, database, there it is, update. So database update, it is extending database, which is again abstract. Let's go out there. I mean, to some of you this might be very boring to see how this weaves together, but because you also understand this. But for others, and it's for your sake, that I'm just showing you around, just taking you through the rooms. Okay, so here's our abstract database. It basically has a dependency of the Joomla database driver and the table class. No, wait, just the table value, that's the string. And this is an interesting part, because here we have a class called helper get code. Now the component helper class, this one here, is a class that I wrote because the way I want powers to be, it's kind of decoupled from the component. So that if I use the same power in another component, it must just automatically adapt to that component and basically know it's working now with that component. So doing that, we have this get code table method. Now, I realize there is some more thought needed here, but this is the implementation that we currently have. And what this get code function does, let me take you to that. I think it's, let's see, let's open a new folder here. I think it's in the utilities folder, and it's component and it's helper. So what that does is we have here the option as a string parameters, and we are calling this get code. Now you could tell it what is the option. Now what does option mean in Joomla? You know, you have this value in the array called option equals, right? So it's basically talking about this value. Okay, that's the value that we're talking about. This value here. So if no option is called, we're going to do get option. So what does get option do? Let's see, where is get option? Ding, ding, ding. Here's get option. So it's going to check again, blah, blah, blah. Otherwise, it's going to do the input get string option. So it's going to check at the URL and it's going to pull the option from the URL, which is the only option that I thought would be valid. Now, if there's another way to get that option that is more stable, then please let me know. But even if you've got search engine optimization activated, this value gets retrieved because of the router behavior. This means that now here we have our option, we return it. Otherwise, we're going to return the default, which in this case would be empty. And then everything will not work at all. So going back to our previous code, we are basically saying, who are we working with? Give us the code. So this is underscore underscore. And in JCB, the way that we build classes is we are going to use the code. That means going up here, get code, which we strip the com from the code. Yeah, so we're going to say, is this a string? And does the string have com? If it does, strip it, trim it, and stir to lower, return. This means we are returning only the actual extension name, okay? And this I'm using to build the initial table value. Now, when we do get table, we're going to use this initial table value and the actual table name. You remember when we looked at the table class, it only showed us the name. It didn't add the extension's whole, value. So here we are basically building the whole table name. This is useful. Another function that I added that I found useful is to determine what kind of value are we working with. Are we working with an integer? Sometimes a integer is in a string, but it's actually an integer. So we are using this to determine that it's an integer, and then we're casting it as an integer and we return it. If it's a float value, then we cast it as a float and return it. If it's a bool, then we deal with it this way. If it's a date, we try and deal with it that way. And otherwise, we fall back to the Joomla default, which then would deal with it by adding a quote. Yeah, so this is because we don't know what value we're working with, this gives us an easy way to deal with that. And so this is not the modeling, this is just getting it ready for the database. Yeah, this is something I'm very eager to hear anybody give me better insight on that. Okay, so this is our base database abstract class. You cannot call this class directly because none of its functions are static. So you must extend this class. This is its reasons for existing. And so when we go back to our power, go back to our database on update, this is the database class that we have, and this is our model. So when we do work with a value, then we're gonna basically use the key, the value. Now, the key in our power area, we don't want to use IDs because we want to work between different systems, right? We don't want to always search, does this ID exist? Is it the same value? Is it this, is it that? And that's in fact why we moved over to global unique IDs a long time ago in JCB, is just to take our data out of the argument of duplication and collision. Now I know global unique IDs still have a 10 million or somewhere there probability. There is a place where collisions can still occur, but yeah, um, let's see how long that takes. It is quite a large number, and since you may not even be using all powers in every project, you just use some powers. Now, the way that the global unique ID, in any case, is generated, it actually checks that there isn't that specific global unique ID in that specific database when it generates it. There is that catch. So it is the best approach I have found, which is the lowest on resources. Obviously, nothing competes with an integer, um, but since integer is problematic, this is the reason why we did this. So we're basically prepping with the key. We are saying you must give us the global unique ID and the value. And so, wait, global unique ID, the value for, this is the value and the value key, that's right. So we're basically building an array and then passing it over to the row. And the row takes that and models it and passes it over to the database. Yeah, simple as that. And the same for rows, that's how that's done. And for items, for an item and for items. So that means that the model has an items function and this one has an items and the database has an items. So they kind of line up, you see that. So this works very well. It's kind of predictable. Even if you go back to these classes and try and see how did this happen and that. And since it's dependency injected, this is a very stable update class. It works very well. Updates is kind of tricky because you can't really, as far as I know, do bulk updates effectively. So here's the insert. Now insert there again, this we can do bulk. So if you go into the database way of doing it, yeah, it actually has some interesting way of dealing with it. Wait, let's look at that again, insert. So we are using the same model, and except now here we're doing the insert database. So let's see, going out here, database, and there it is, insert. Here's our insert value. And we do have a limit of 300 items. And if we trip that limit, we are going to update the database, reset, first year update the database, then reset our limit, and then repopulate our query and start loading the next set. And here we are loading our set. And here we're dealing with defaults, or rather whether we are working with defaults, create versions, and these kind of things. And that's basically it. This is the last option to check whether there is something to update, and that's the insert value. So here we get the object column. Yeah, you could look through this. This is how we do in a global, we got this global insert class, and it's taking care of just adding stuff to the database in a very bulky way. And the update one, again, does it more, row by row. So even if you have an array, even if, well, what is this? This is a data, an array of arrays, okay? And this is an array of objects, that's items, and this is a array, and this is a object which we cast to an array. Yeah. Okay, so that's how the update one works. And then we have a load, and load is basically to pull again data from the database. So that's how that architecture works. Now, here is our superclass. The superclass is the one that we are using to basically load a global unique ID. It passes the order to grep, our grep class, and if it finds it, it is going to store it. That's right. The super is the class which is going to store it, and it's going to detect what it needs to do. Is the action, is it an insert or an update? So the action basically takes our global class called global unique ID helper, and it takes the global unique ID and it takes the table and it checks whether we have an ID. And if it is not null and the ID is more than one, it says update. Otherwise, it says insert. And so it takes care of whether we're going to insert or update right here. These are the methods that deals with that. And it's also dependency injected. So this is the final class. The final keyword is the way to prevent this class from being extended, and makes sure that whoever uses this is going to use dependency injection to instantiate it, or at least it's going to pass this into it. Okay, yeah. And so we are only calling the load method. That's the only method that's public. And now, let's see. That's our superclass. Now, that's basically the flow of once we have the global unique ID, and we now know, okay, it's obviously, we're going to go search for it. Now, the reason why we do have update, whereas all the demonstrations I've shown so far, we're actually doing insert, right? We don't have it locally, so we're going to go look for it and insert it. The reason why update is there because of the buttons that we have in the power area. There is one called reset, and there is one, let me just look at it, sync, reset. Now init is the insert, whereas sync and reset is going to probably deal with updating some of the data. So these classes are basically what's going to do that work for us. Now the classes that actually search through the code of your JCB extension, and actually discovers this placeholders and then tells the system to fetch it and everything, is not part of this classes. It lives lower down in the compiler class. So if you want to see that, the compiler class, you need to go to the power folder here, and you'll see that there is a function here called extractor. And it's this extractor that is searching. Here is it searching for the superpower placeholder. And it has a different way at times that, we have a reverse searching, we have a get search, we have a search, and we have a load. So there are different methods here that does different things in different times of the compiling process. I mean, one of the things that we wanted to ensure is that if you do custom coding in the IDE and you do that reverse update, then while you're working in the IDE, you might have, this value is no longer there, right? It's been updated. So the code that you're working on in the IDE, when you do a reverse code update, the superpower key is no longer there. And so what we did is we discerned that, okay, that data, that value, that code that you're working on, at that very moment, the data in the database still has that set keys. So we're basically pulling from the database the existing power, and then we are searching through that specific power to make sure that we don't lose the codes. And then so we're reverse engineering, and I think we're doing that with the injector. I'm not sure. Yeah, it's using the extractor, the parser, the placeholder. So I'm not sure if it's here. I mean, I think so. So there's a whole reverse engineering method that we have employed to make sure that we were able to map the code correctly back to take your changes, put it back into the database without losing these keys. The same with the language string, right? If you're working on the code in the IDE, the language string is usually already in a capitalized key way. Now, if you want to reverse engineer that and you're working on the code, but you want the code to be updated in JCB, then we are actually reversing even the language string so that your language strings don't get lost. And that's part of what makes many of these things quite challenging. But okay, that's kind of it. I wanted to share with you how the search of the superpowers work, and also the classes where this is done, so you could look at it and understand a little bit more of what is happening. Basically, this is the path to that code, and yeah, I hope this has been useful to some of you. Take care. Until next time.